Hey everyone, we are going to go over 3.3b in this video, which is all about analyzing the graphs of quadratic functions. So in the last section, 3.3a, we talked about how to get the equation written in vertex form, right? Because when it's written in vertex form, it's very easy to identify the vertex, to know if you have a maximum, a minimum, if it opens up, if it opens down, all that good stuff, right? So today we're going to be applying that to some word problems, okay? Now, when we deal with word problems, our numbers aren't always easily managed, we'll say. Sometimes we have decimals, sometimes we have fractions, sometimes we have a combination of decimals and fractions, and that's not necessarily something we would want to have to use completing the square in order to get it into vertex form, because it gets a little nasty, right? So today I'm going to show you what we call the shortcut, okay? The vertex form shortcut. Now, if you can remember this shortcut, that's wonderful, and you can use it and everything will be peachy. If you can't remember it, or you're not 100% sure, you can always solve these problems working it out using the completing the square method to get it into vertex form. Okay, now there was a worksheet due on 3.3a, and on that worksheet, I want to see that you worked it out using the completing the square method. So if you have not done that worksheet yet, make sure you complete it using the completing the square method that I went over in the last video, okay? You cannot use the shortcut for that worksheet, okay, or you won't get credit. Just because I want to make sure that you had some practice doing it the initial way before jumping into kind of the shortcut. All right, so here's what the shortcut looks like. We want to end up with our function written like this, right? This is our vertex form. And when it's written in standard form, it looks something like this, right? So remember, what we went over in the last video is we moved the c over, we divided off the a, we took half the middle term, squared it, added it to both sides, right? So what we're hoping to get is to be able to identify this h value and to be able to identify this k value, because that gives us our vertex, right? So we're going to kind of think about this going backwards. If I happen to know the h and k value, I could easily write any function in vertex form, because the h, I would just plug in here and write it as x minus whatever that h value is. Whatever my k value is, if it's positive, I just add it out here, right? If it's negative, I subtract it out here. So knowing these two values allows me basically to write all of this piece of the vertex form. The only other thing I would need to know is the leading coefficient, which we would already know given the function in its standard form, right? So that's what we're looking to do today, is we want to be able to find the vertex, because if we can find the vertex, we can plug in the h value, the k value, and that leading coefficient, and we'll be able to have it written in vertex form without having to complete the square. Okay, so here's our shortcut. Here's how we find it. Okay, to calculate our h value of our vertex, the thing that's going to go in here, right? We calculate negative b over 2a. Now this b and this a are the coefficients of our terms when it's written in standard form. Okay, so whatever the coefficient is on our x term, that's our b value, which we're negating. And then whatever our leading coefficient, our a, that's what we're multiplying by 2 here in the denominator. Okay, so that's how we find our h value. And then once we know what our h value is, let's say this negative b over 2a ends up being like 5, right? Once we know the h value, or the x value, right? Once we know the input, we can always find the output by then just plugging that back in. So whatever we get as our answer here, in order to find our k value, we just plug our h value back into our function, okay? So let me go ahead and show you what this looks like. So here is our function in question, right? So here we can see that our a is going to be -1, right? Our b value here is -4, and our c value here is 5. So if I want to find my vertex using that shortcut, I know that the h value of my vertex can be found by calculating negative b over 2a. negative b over 2 times a. So I'm going to plug in my values from this specific function. Okay, so b in my case is a negative 4, and this says to do negative b. So in other words, the opposite of negative 4 divided by 2 times my a value, which in this case is negative 1. 2 negatives on top make it a positive 4 over a negative 2. And then that just simplifies down to negative 2, right? So what we have determined so far is that our vertex's h value is negative 2, okay? Now that I know what my h value is, to find my k value, I just take whatever my h value was, in this case it's negative 2, and I plug it back into the function, okay? So in other words, to figure out what k is, I'm going to take my function and I'm going to plug in whatever I got for my h value, okay? So I'm plugging negative 2 into this function. Remember, when we evaluate functions, we put the number in the parentheses anywhere we see an x. So notice we have a negative in front, and then we take whatever our x is and we square it. Then we have a negative 4 times whatever our x is, and then we're adding 5. So I'm just writing out what the function does, and once I've written out what the function does, now I can go ahead and put in my input, which is a negative 2. And now I just need to simplify. So I do exponent before multiplication. So exponent squares my negative 2, which makes it a positive 4, right? And then I still have this negative out front, so that's going to make it a negative 4. Negative 4 times negative 2 gives me a positive 8. And then I also have that addition of 5. So now I just need to combine these, okay? Negative 4 and 8 gives me a positive 4. And when I add 5 to that, that gives me 9. So now I know that the second value in my vertex, or my k value of my vertex, is 9. Okay, so up to you if you think that was easier or harder than completing the square. So now that we have our vertex number, now we should be able to write this in vertex form, right? Vertex form looks like a times x minus h squared plus k. Okay. So this is a formula that you will be given on, like, for an exam. If I ask you to put something in vertex form, I won't have this labeled vertex form, but it will be a formula that's on your formula sheet. But you will be responsible for knowing when to use this and what all the letters stand for. Okay. So we need to plug in first our leading coefficient, right? My a value here, remember, was negative 1, or we can just write it as a negative. And then we do x minus our h value. And we found our h value to be negative 2 squared plus our k value, right, which we found to be 9. So this is our vertex form. We just need to simplify it now. So I have f of x is equal to negative in front of the quantity x plus 2 squared plus 9. So here's my vertex form. And we also found our vertex. So this is kind of the idea, is that if we can use this shortcut of finding negative b over 2a to find our h, and then taking that h value and plugging it back into the function to get our k value, then knowing the vertex and the leading coefficient allows us to write this in vertex form a lot easier. Okay, let me show you one more of using the shortcut, and then I'm going to have you try it just so you can get some practice with it. Okay. All right, so on the next page, right, this one looks a little bit worse because we have some fractions in here, but we're not going to freak out because our ultimate goal is to be able to find our vertex, vertex ordered pair, right, and then to be able to find vertex form, which looks like f of x is equal to a times x minus h squared plus k. So that's where we're headed. And remember, our shortcut is that we can find our vertex by doing negative b over 2a, and then whatever we get for that, plugging it back into our function f of negative b over 2a to find our vertex values. Okay, so let's go ahead and use this problem to calculate our vertex. So our a here is 1/2, our b is negative 3, and our c is 5/2. So we're going to go ahead and plug in. We're looking for our h value first, which we know we can find by doing negative b over 2a. So I take my b value here, which is negative 3, and I'm doing the opposite. So the opposite of negative 3 is going to make that a positive 3, right? All over 2 times my a, which in this case is 1/2. Okay? So we end up with a positive 3 over, now half of 2 is 1, right? And I do want to mention here, if the problem is given to you with fractions, most likely they want you to express your answers with fractions. So don't change it to decimals if there's not decimals in the problem, okay? All right, so our h value ends up being 3. So that's the first coordinate of our vertex. Now to find the second coordinate of our vertex, or our k value, we're going to plug whatever we got for h back into our function. So we're going to do f evaluated at our h value, which was 3. So 3 is what I want to plug in everywhere I see an x in my original function. So I'm just going to write out what my original function does, and then I'll plug in the 3. So my original function says to do 1/2 times my input squared minus 3 times my input plus 5/2. Okay? And now I'm going to put my input in the parentheses, which in this case is 3. Okay? So on this first one, I do the exponent first. So 3 squared gives me 9. So I have 1/2 times 9. Negative 3 times 3 gives me a negative 9. And then I have 5/2. So when I look at this, when I multiply, half of 9 doesn't come out pretty, right? It's like 4.5 or 4.5 or something. And I don't want to do decimals. But I could think of this as 9 over 1. And when I multiply this, I could just write it as 9/2. And then notice this number also is written as some number of halves. So I'm just going to write all 3 numbers with the denominator of 2 so that I can combine them easier. Okay. Now this one, the negative 9 in the middle, the denominator right now is a 1, right? So if I want to write it as a certain number of halves, I'm going to have to multiply on top and bottom. And to make my denominator 2, I would have to multiply on top and bottom by 2, which would make this negative 18 over 2. And then my last term, 5/2, already has a denominator of 2. So now that they all have the same denominator, I can go ahead and combine. 9/2 minus 18/2 is negative 9/2, plus 5/2 leaves me with a positive 4/2. Right? And then 4/2 is just 2. So that means that the k value of my vertex is 2. So now that I know the vertex, I can go ahead and put it in vertex form. Okay? Vertex form says to do my leading coefficient, or my a value, which in this case is 1/2, times the quantity x minus my h value. So x minus my h value, which is 3 here, squared, plus my k value, which we found to be 2. And there's nothing here I need to simplify. So here is our vertex form. Okay? So make sure on your homework that you're paying attention to whether it's asking you to find the vertex itself or vertex form, or both. Okay? All right, so here's a practice problem for you to try. The bottom of the page, it wants you to write it in vertex form. So it wants your answer like this. So you first need to use our shortcut to find your vertex, and then plug your vertex and your leading coefficient in so that you can write this function in vertex form. Okay, go ahead and pause the video and give that a try. And then when you're ready, or if you get stuck, play it and we'll go over it. All right, let's see how you did. So first thing we need to do is figure out our vertex. We find our h value by doing negative b over 2a. So our b value is 5. We do negative 5 because we're doing the opposite of b over 2 times our a, which is negative 1/2. And negative 1/2 times 2, or half of 2, is 1. And since it's negative, we end up with a negative 1. And then negative 5 over negative 5 gives me a positive 5. So excuse me, that's our h value. To find our k value, we then take that h value and plug it back into our function. So I have written out our function with my input as 5, And when we do our simplifying, we should end up with 9/2 as our K value. Okay, if you got lost somewhere in here, go ahead and pause the video, make sure you understand where your mistake was. If you got to this vertex point, great. Now we just need to take that vertex and our A, which is -1/2, and plug it in to get our vertex form. So our vertex form says to do our leading coefficient, which is -1/2, and then we do x minus our h value, which in this case is 5 squared, plus our K value, which we found to be 9/2. And that's all we have to do, okay? All right, so now we're going to go ahead and move on and look at those applied problems. So our application problems are going to be using this idea of vertex. So remember our vertex point, when we talk about calculating a vertex, it's our highest or lowest point, okay? So just recall, when we talk about vertex, we're talking about some parabola, and it's either the lowest point, or if the parabola is opening downward, it's the highest point, okay? So when you read through these problems, you need to be thinking, is this a reference point that could be the low point on a parabola or the high point on a parabola, or is it not, okay? If it's not talking about a minimum or maximum value, then we're not talking about vertex. We're talking about maybe just solving it normally for x. Okay, so let's read through our problem. And like it says here, the most important thing you need to know before calculating anything is what your variables represent. Meaning, if I were to create an ordered pair for this application problem, what is going in, what's my input, and what's coming out? What's my x, what's my y, okay? So let's go ahead and look at this first one. This first one says we're talking about the height of a projectile, okay? So think about projecting something, okay? That's going to create some type of a parabola shape, right? It says a stone is thrown directly upward from a height of 30 feet with an initial velocity of 60 feet per second. The height of the stone in feet t seconds after it has been thrown is given by this function. Determine the following, okay? The time at which the stone reaches its maximum height. Now I'm going to stop right here and just underline this. Anytime you see the word maximum or minimum, you should be thinking vertex, because that's either the lowest or the highest point. So because this one says maximum, it's like we're throwing this stone up in the air, it's going to hit a maximum height, and then it's going to come back down. Does that make sense? Okay, so you can think about this of, you know, maybe here's our 30 foot, and we're throwing this stone up, and then it's coming down, and, you know, whatever. So this is what we have. This is going to be our vertex point. We know it's a maximum, right? So anytime you see this word maximum, I would go ahead and be thinking vertex. And vertex we find by using our shortcut, which is -b over 2a and f of -b over 2a. Okay. All right. So let's keep reading what they want us to find. They want us to find the time at which the stone reaches its maximum height. They want us to find the maximum height, and then they want us to find the time when the stone hits the ground. So let's look at the function that we're given here, okay? And let's figure out what everything represents. I need to know, what does t represent, what's getting plugged in, and then what's coming out, okay? So let's go back and read. It says, a stone is thrown directly upward from a height of 30 feet, so I see the word height, with an initial velocity of 50 feet per second. The height of the stone in feet t seconds after it has been thrown is given by this function. So the first thing I notice is t seconds. T is what's getting plugged in, and it says here we're talking about t in seconds. So that means we're plugging in seconds or time, right? And what we're getting out is if we plug in a specific time, we should be able to figure out the height, okay? So I'm going to go ahead and say the height here, which they said is in feet, okay? All right, so now we know what our function represents. We're plugging in seconds to figure out the height at that specific time. So for part A, it wants us to find the time, okay? So if it wants us to find the time, that means we're looking for that first coordinate, right? Or our h value. So if we're looking for the h value of our vertex, we can find that by our shortcut, which is negative b over 2a. So let's go ahead and plug in our values with this function. So negative b, my b is 60, so negative b would be negative 60 all over 2 times a, which here is negative 16. Okay, so negative 60 does not simplify to anything. 2 times negative 16 is negative 32, and this does not reduce nicely, right? A negative over a negative is positive, which I can go ahead and simplify, but also it really doesn't make a lot of sense in an application problem to say the time at which, you know, the stone reaches its maximum height is at 60 over 32 seconds. That doesn't make a whole lot of sense. So I'm going to go ahead and change this into a decimal because it does turn out to be a nice, pretty decimal. So we're going to say this is 1.875 seconds. Okay, I moved it down just a little bit because I don't want to run into this writing. All right, so we first calculated negative b over 2a to figure out the time, because that's what my input represents, right? And it wants to know the time when it reaches its maximum height. So in terms of our vertex, right, what we know here is that it takes 1.857 seconds for it to reach its maximum height. We don't know what that maximum height is, right? Because that's our second coordinate in our vertex. So now let's look at part B. So part B says we want to find the maximum height. So now we're looking for the maximum height. That is our second coordinate. So to find our second coordinate, if we look at our shortcut here, we take whatever we got for h and we plug that back into the function. Now I miswrote this. Here our function is called s, and I wrote it as an f. Okay, so we could write this as s. Whatever we get for h, we plug it back into our s function, okay? I'm used to writing f because a lot of times we label everything as f of x, but if it's any other function label, we work it the same way, okay? All right, so we're going to take our 1.875 seconds and we're going to plug it back into this height function. In other words, I want to evaluate the s function at 1.875. So I'm going to go ahead and write out what my s function does, and then I'll put that input value in, okay? So my s function takes negative 16, multiplies it by our input squared, and then it adds 60 times our input, and then it adds 30, right? So all I did was write out the s function, and I left parentheses where my input is. So now I can go ahead and put in my input, which is 1.875. 1.875. And now I just need to simplify in order to figure out what that maximum height value is. So I'm going to square the 1.875 first because we do exponent before we do multiplication, right? So I have negative 16 times. If I square 1.875, we get 3.515625 plus 60 times 1.875 gives me 112.5 plus 30. Okay, and then I need to do this multiplication. When I multiply 16 times this decimal number, I end up with negative 56.25 plus 112.5 plus 30. Okay, so I go ahead and combine here. And I'm just going to go ahead and tell you what this equals. I'm not going to write it out one step at a time because I believe in my heart that you can punch this into your calculator and get the correct number. So what we end up with when we combine all of this is 86.25. Okay, and remember what our function does is it puts in time and it gives us out height. Okay, so we put in 1.875 seconds, and what we're getting out is the height in feet. So this is 86.25 feet. And that's the second coordinate of our vertex, 86.25 feet. Okay, so A and B were both related to that vertex point. But notice if I look at part C says we want to find the time, okay, when the stone hits the ground. Now, if I look at my little picture that I've drawn, I throw this stone up, it hits its maximum point up here, which is my vertex point, and then it comes down. Where it hits the ground is going to be somewhere over here, right? So if I think about this on an XY axis, this is like the x-intercept, right? Where it's going to come down and just hit the ground at a height of 0, right? So that has absolutely nothing to do with my vertex. So even though it says time, that lets me know I'm solving for t. And if I'm solving for time, that means I should know the height of it, right? Because if we ask you to find the time, you should know the height. If we ask you to find the height, you should know the time, right? We're not going to make you find both things. You have to know at least one. So if we're looking for the time, we should know the height when it hits the ground. And when it comes down and hits the ground, its height, right, is 0 at that point. So I'm just going to take this function and I'm going to set the height equal to 0. So remember, the height is our y value, or our s of t. Our output gives us our height. So I'm just going to set this whole thing equal to 0. So we know that the height is equal to 0. So we're going to go ahead and write, oops, I don't know if I can get it all on here. Our function 0 is equal to negative 16t squared plus 60t plus 30. All right? So we set it equal to 0, and now we just need to find the time in which that happens. Now, we could do this a couple of ways. We could do sum product, or we could do completing the square, or we could do quadratic formula. Most of the time, if I have a quadratic equation and it's a word problem where I don't know if it's going to come out pretty, because notice my other answers really didn't come out pretty, I'm going to go ahead and default to the quadratic formula, just so that if it's not factorable, I can still get an answer. Okay? All right. So I'm going to go ahead and say negative 16 is my A, 60 is my B, 30 is my C, and I'm going to go ahead and just write the quadratic formula up here for those of you who don't have it memorized. The quadratic formula says that t is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, it's all over 2a, not just the radical. The whole thing is a fraction over 2a. Okay? All right, so let's go ahead and plug in our values. So t is equal to the opposite of b. So if my b is 60, then the opposite would be negative 60 plus or minus the square root of b squared. So 60 squared minus 4 times my a, which is negative 16, times my c, which is 30. All over 2 times a, which is negative 16. Okay, so I have everything plugged in. Now I just need to simplify. So to simplify, I still have negative 60 plus or minus the square root. 60 squared gives me 3,600. And when I multiply these next three numbers together, I'm going to get a positive, right? Because I have two negatives. Negative times negative is positive, times another positive is positive. And 4 times 16 times 30 gives me 1920. All over negative 32. Okay. So I keep simplifying. So this gives me negative 60 plus or minus the square root. When I combine my two numbers under the square root, I get 5,520 all over negative 32. And unfortunately, 5,520 is not a perfect square. It comes out to a decimal. So I'm going to go ahead and just put a decimal approximation on my paper. But when you work this out, make sure you leave all the decimal places on your calculator so your answer is correct. Okay. So this gives me negative 60 plus or minus. When I take the square root of 5,520, it gives me 74.29 and a bunch of stuff. I'm not going to write it out, but make sure you save that in your calculator. All over negative 32. Okay, so I need to write out the two answers that I could get here because I have a plus and a minus, right? So I need to do negative 60 plus 74.29 blah, 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 blah over negative 32. And I need to do negative 60 minus 74.29 blah, 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 blah over negative 32, right? So all I did was just write out this problem, but I did one with the positive and one with the negative. That way I can work out each one, okay? So when I do negative 60 plus 74, and then I divide that by negative 32, that's going to give me a negative 0.446 and some more stuff. When I do negative 60 minus negative 74 and divide it by the negative 32, I'm going to end up with 4.196 and some more stuff. Okay. And we're going to pause just for a minute because that was a lot of calculating, and we want to make sure that we know what it was we were solving for. So I'm just going to go back up here and read part C again. So remember, we're looking for the time when the stone hits the ground. So if we're looking for the time and I look at the answers I can't have a negative time, right? No negative time. So what we're saying is that this has to be our answer, right? It's going to go ahead, we're going to throw this rock up, it's going to hit its maximum height, it's going to come down after about 4 seconds, right? And my math lab will tell you exactly how to round. Here, I'm just going to go ahead and round to 1 decimal place. I'm going to say 4.2 seconds, okay? About how long until it hits the ground. Okay. All right. So we were able to find out 3 pieces of information from just this one problem, right? From just the vertex, we were able to find how long it takes to reach its maximum height. Then by plugging that number back in, we found out what the maximum height was. And then by setting the function equal to 0, we were able to figure out where or after how long will it hit the ground. Okay. Let's look at another type of word problem that we can use either setting it equal to 0 or finding the vertex in order to simplify it. Okay, so let's look at this page and we're going to talk about maximizing area. Now again, anytime you see this word maximize or maximizing or minimizing or minimize, right, you should be thinking vertex. Okay, so I'm going to go ahead and just put what my vertex shortcut is. My vertex shortcut is negative b over 2a, and then we can take that and plug it back into our function to find our k value. So this would be our h, this would be our k. All right, so we know we're going to be talking about vertex in some way, and we know how to find our vertex, but we don't have a function here. So we need to come up with a function. And remember, vertex is talking specifically about a quadratic function. Okay, quadratic functions have an x squared, right, in them. So we need to come up with something that has a something squared before we can even use this. So let's see what our relationship is here. It says, a berry farmer needs to separate and enclose 2 adjacent rectangular fields, one for blueberries and one for strawberries. If a lake forms one side of the fields and 240 yards of fencing is available, what is the largest total area that can be enclosed? Okay, so I see 2 words that are not related. I see 240 yards of fencing, right? Fencing is what I would use to make these fields, to fence them in, right? The outer perimeter of them. Okay, so this has to deal with perimeter. Perimeter, right? But then in the same sentence, it says, what is the largest total area? Okay, so we're talking about both area and perimeter. So I'm trying to figure out, okay, well, what is it what are we maximizing? Are we maximizing perimeter? Are we maximizing area? What are we talking about here? Okay, so I'm going to read this last sentence again. If a lake forms one side of the fields and 240 yards of fencing is available. Okay, they're just saying that is all the fencing we have. That has to cover the entire perimeter. Okay, that's non-negotiable, right? So that's not something that we're maximizing. That's just telling us this is how much you have for the perimeter. What is the largest total area that can be enclosed? So we are maximizing the area. Maximizing area. So that means we want to end up with a function of area. Like the area given something looks like blah, 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 right? So we need a function of area that we can use our vertex shortcut on, okay? Now we don't have a function of area yet, but this is where we want to end up. So let's go ahead and label what we know here. We know how to find perimeter, right? Perimeter is all sides added together. So notice we don't have to worry about this side because there's a lake there, right? Is that what it was? A lake? Yeah, there's a lake here that forms this side. But I do need these three lengths, right? I have this length, and this length, right? And then I have this entire width across the bottom, right? So my perimeter has to cover all of that fencing needed. In other words, perimeter is equal to 3 of these L lengths plus the 1 long width length, right? Okay, so we know perimeter and we know how much perimeter we have. We have 240 yards to cover that, okay? But notice this is not a quadratic function because we don't have a variable that's squared here. So this is going to be important, but it's not our area function, right? So let's look at area. If I wanted to find the area of this whole piece of land that we're hoping to use for this farmer, right? Area, we do length times width, right? So if I do this length times this width, it covers that whole field area that we want to use, okay? And when we multiply, that is a way that we can end up with a square, right? So what I want to do is I want to use this as my formula for area, right? But I don't want both length and width there because I just need to work with one variable, not two. So what I'm going to do is I'm going to take my perimeter relationship here, and I'm just going to solve it for either L or W, whichever one is easier to solve for, and then plug it into our area formula. So if I look at my perimeter here, this one is the easiest one to solve for, W, because it's almost already by itself, right? All I would need to do is subtract this 3L to the other side. So that means that W is equal to 240 minus 3L, right? So now what I'm going to do is take this and plug it in for W in my area formula. So now we can say the area is equal to our length times our width, which we now can replace as 240 minus 3L. Okay? Does that make sense? We use an existing relationship of perimeter to solve for either length or width. It wouldn't matter which one you do. I chose to solve for W because it was the easiest one to solve for. And then I'm going to plug that into my area formula because now notice when I multiply this area formula, area is equal to 240L minus 3L squared. Now we have a squared function, right? Or a squared relationship. So now I can go ahead and write my area formula. Okay, so area is what we get out, and what we're putting in is L. So this is an area function given the length L. And I'm going to go ahead and rewrite it with the leading coefficient first. So negative 3L squared plus 240L. So this represents plugging in a length and getting out an area. Okay, so we're trying to figure out what is that maximum total area that we can get. So if we're plugging in a length and we're getting out an area, this is what we want to end up solving for, right? Because we're looking for the largest total area. So if we need the second coordinate in our vertex, or we need the output, then what we need to calculate is our function evaluated at negative b over 2a. Okay, so we first have to figure out what is that length that would give us a maximum area, and then we'll plug it back in to figure out what the maximum area actually is. Okay, all right, so first we're going to find the length. So our length we find by doing negative b over 2a. So I'm going to go ahead and calculate this using my function I just came up with. the opposite of my b, well, my b is 240, so the opposite of 240 would be negative 240 over 2 times my a, which is negative 3. So negative 240 over negative 6. And then this reduces, right? This comes out to a nice pretty 40. All right, so remember, this is just us using this vertex shortcut to figure out what the first coordinate in my vertex is, which is my length. So our length is 40. And remember, we're talking about yards. So 40 yards is my length. Now, is that what we're solving for? No, right? We're not looking for length and width. In this one, we are looking for the largest total area. Now, there will be problems where it will ask you to find the length and the width. And once you find the length, you could then plug that back in over here, right, to figure out what the width is. But it didn't ask us about the different dimensions. It's asking us for that total area. So to find the total area, now that we know this first coordinate, to find the second one, we take whatever we got for the first one and we plug it back into the function, right? So in order to find the area, we need to plug the length that we just got, which was 40, back into our area function. So our area function says to do negative 3 times our input squared plus 240 times our input. And what we're inputting is that length that we just discovered was 40. Okay. So 40 yards is what creates a maximum area. Now we just need to figure out what that maximum area is. We do our square before we do our multiplication. So this gives me negative 3 times 1600 plus 240 times 40 gives me 9,600. And then I go ahead and multiply my negative 3 and my 16, which gives me a negative 4,800 plus that 9,600. When I add those together or combine those, it gives me a positive 4,800. And remember, the second coordinate represents my area. So that means my maximum total area would be 4,800 yards squared. And that's what we were looking for. Okay, so I'm going to go back and just kind of talk through this because I know it's a lot. Most people are very offended by this problem just because it's like, where did you get all of that? So I just want to go back and talk you through it. And then there's 2 problems on the next page that you can try. Okay, so first of all, maximize told us we're looking for a vertex. So I went ahead and wrote my vertex shortcut. And we need to come up with a quadratic function, something that has a square in it, so that we can calculate that first coordinate and second coordinate of our vertex point, okay? So we pulled what we knew from the problem. We knew we were looking for the largest area, so we knew that this is where our function was going to come from, because the largest total area means we're maximizing the area. We need a function of area so that we can use our shortcut to find that vertex, okay? Now, area is length times width, and that's 2 separate variables. We can't have 2, we just need 1. So we either need to write area in terms of length or area in terms of width. We also had this additional relationship that we had 240 yards of fencing, which means that my 3 lengths and my 1 width has to total 240. So this was a relationship that was very easy to solve for W. And that way we could replace the W and be able to write our area with only L's, okay? So once we can write our area with only L's, then that means that we can create a function of area given any length, okay? So given any length that we plug in, we have this function that represents the area given that length. So now that we know our input is length and our output is area, we can maximize that area by figuring out our vertex point. So we find our initial h value, right, which here represents our length, by doing negative b over 2a, and we got 40. So that means each of these would have to be 40 to create a maximum area. Okay, now that's not what the problem asked us, but it was a step we had to figure that out in order to find the maximum area. So now that we know that the length is 40, we plug that back into our area formula to figure out what our maximum area is. And we came up with 4,800. Okay. Again, on problems, it may ask you to plug it back into the formula you came up with to find that maximum whatever, or it could just ask you for the dimensions. So in this problem, if it had asked you what are the dimensions that maximize the area, once you found the length here of 40, you wouldn't have to plug this back in, right? You could stop and say, okay, well, I know the length is 40. Now let's find the width. And you could just plug back in 40 for L here to find the width, okay? So make sure you're paying attention to what your problem's asking you. All right, so on the next 2 pages, there's 2 for you to try. I'm going to go ahead and let you pause the video. If you get stuck or you need help, let me know and we'll go through them, okay? Okay, I'm going to do my best to make this fit. I can't fit the whole problem on here, but we're going to go ahead and talk through this one. So this one's talking about the height of a rocket, and a rocket is launched with an initial velocity of 120 feet per second from a height of 80 feet, and it gives us the height of the rocket, okay? Height of the rocket in feet, t seconds after it has been launched. So right away, we know that what we're plugging in, t, is our seconds, right? So I want to write that as our time or seconds, whatever you want to do. And what we're getting out is the height of the rocket, okay? So before you start working anything, make sure you know what's going in and what's coming out, because that will help you determine what you're solving for in your vertex. Do you need the first coordinate, or are you solving for the second coordinate? Because sometimes it will just ask you for one or the other. It won't always ask you for both. So you need to make sure you know which one represents what. So here we're plugging in time to get out height. Part A asks for the time where it reaches the maximum height. So again, that word maximum tells us we're dealing with a vertex. So I went ahead and wrote our shortcut here. And since we're looking for the time that creates that vertex point, we're looking for this first coordinate. So we do negative b over 2a, and we plug in our values and simplify. It comes out to 3.75 seconds. So after about 3.75 seconds of this rocket being launched is when it will reach its maximum height. Okay, so make sure you label that seconds. And then part B, it's asking for the maximum height. So again, you see that word maximum. We know it's referring to the vertex point, and the height is the second coordinate of the vertex point. So in order to find that second coordinate, I take whatever I got for my first coordinate, in this case 3.75, and I plug that back into my function. So we're going to go ahead and plug 3.75 back into our h function. And I hate how this is typed. I'm sorry that that got separated. But our h function says negative 16 t squared plus 120t plus 80. So just write out that function and leave parentheses where the t's were so that you can put in your 3.75 as your input. When you simplify that out, we should end up with a maximum height of 305 feet. Now, after we've done part B, that's all we can determine from this vertex. Like, we've used up the vertex shortcut. There's nothing else we can get from that. So part C, we have to already be thinking in our head, is not going to be using the vertex because we've already determined both pieces on part A and B. So part C says that we want the time when the rocket hits the ground. So again, when something hits the ground, its height is 0. So we're looking for the time where the height is 0. So all we're going to do is plug 0 in for our height, or in other words, set our function equal to 0. And then in order to solve this, you could go ahead and try to factor it. I default to the quadratic formula. Okay, so you plug in negative 16 for A, 120 for B, and 80 for C. And when you work it all out, and I don't know why I have it erased here. Okay, there we go. I skipped steps apparently. But once we get it all worked out, we end up with a negative answer, which we can't use because we're solving for time, and we end up with a positive answer. Make sure you check MyMathLab. It will tell you in the instructions how it wants it rounded. Okay, I went ahead and just rounded to 2 decimal places, which would be about 8.12 seconds. Okay, all right, let's go ahead and look at the second one. All right, so the second one is very similar to the second example I did, right? Maximizing area. And this one even tells you we're maximizing area. So when we're maximizing area, that means we need a function that gives us area. So maybe we're plugging in a length to get area. Maybe we're plugging in a width to get area. But we're coming out with something that should have a something squared, right? And should be relating to area. So here it says a 4th grade class decides to enclose a rectangular garden using the side of the school as one of the sides of the rectangle. What is the maximum area that the class can enclose using 32 foot of fencing? What should the dimensions of the garden be in order to yield this area? All right, so you can see here, here's our little garden area. And we're going to use the side of the school for one of the sides. So that means we really only have 2 lengths that we need to worry about and 1 width. Okay, now lengths, width, going all the way around, that's our perimeter, right? And here it said we had 32 feet of fencing. So we know our perimeter is 32. And to get our perimeter, we add all the sides that we're going to be using fencing for, right? Which gives us 2L and 1 width. And then our area is just length times width. So we have our 2 equations here, and we want area, right? Because we're maximizing the area. So this is what we're going to get our function from, but we can't use a function of area that has both a length and a width. So we want to rewrite L or W in terms of the other letter so that we just have 1 letter on this side. So if I look at the perimeter, the letter that's the easiest to solve for is W. So if I take this and I solve for W, I would just move this 2L to the other side by subtracting, which gives me 32 minus 2L, which I can substitute in for W in my area equation, right? So that means that my area is the same as L times what I just substituted in for W, 32 minus 2L. And this is where I can get my area function, because now I can figure out what area is as long as I have that length. Or in other words, I have a function of area given a length L that is 32L minus 2L squared. Now, if you want, you can rewrite this with the L squared term first. If you leave it like this, that's fine. Either way, we have a function of area given the length, meaning we're plugging in a length and we're getting out an area. So this is what I'm going to be using to determine my vertex. Okay, so now that I have my squared or my quadratic function, I can figure out my vertex. The first coordinate of my vertex is the length, and the second coordinate is going to be my area. So let's go ahead and solve for the first coordinate, which is length, and I can do that by calculating negative b over 2a, which gives me 8 feet. Okay, so now I found the length. Now in the example that I did earlier, once we found the length, we plugged it back in to find area, right? To find that maximized area. But I want to look at this problem again and read that last question. It says, what should the dimensions of the garden be in order to yield that maximum area? So they're asking for the dimensions. That means we're solving for our length and our width. So now that we know our length, we actually don't need to know area. So we're not going to plug it back in into our area formula because we don't need to know what the maximum area is. We just want to know the dimensions that create the maximum area. So now that I know that my length dimension is 8, I can go ahead and plug that back into over here where I solved for W to find what my width is. So all I'm going to do is take this length of 8 and put it in for L. So that's what I did down here. W is equal to 32 minus 2L, and I just put 8 in for L, which gives me 16. So that means our garden needs to be 8 foot by 16 foot in order to use the 32 foot of fencing I have available and to get the largest maximum area that we can cover. Okay? All right. Now, I just want to note, if they had asked you to find that maximum area, now that you have the two dimensions, you could just multiply them together to find it. Or, you could have stopped here at the L and plugged it back in to find the maximum area. Okay? All right, so that is the end of section 3.3b. So you should now be able to complete that assignment on My Math Lab. If you have any questions or get stuck, let me know. I'm happy to help.